Here we go. We're going to be in second part of factoring. We're going to be doing perfect squares and difference of squares. Are going to be our focus today. All right, so before we can go backwards, I always like to go forwards. Show where this thing came from, show how it was made, and then we'll work on going the opposite way. So everything we do right now is going to be, I'm going to show you the forwards way, meaning I'm going to give it to you where it looks like this. And we're going to distribute it out. And we're going to see what it looks like as a trinomial. And then in a little bit, I'm going to give it to you as a trinomial, and you're going to make it look like this, because those two things are equivalent. They're just different forms. Does everybody understand at least where we're going with today? We're going to do that perfect squares and difference of squares. So here we go. Let's write this out. What does it mean when I say to square something? Like I said, it's going to look like Christmas up here. I'm going to try to mark crap out of this.
Times itself.
Times itself. That's a perfect answer, because you know what some kids do? Some kids think that this 2 right here belongs to this x and belongs to this 4. And they just distribute it, and that is wrong. That is not the good thing to do. What does it mean when you square something? It literally means you have x plus 4 times what? Now here's what I do. Distribute it out. X times x is x squared. So x times x times 4 is a, and I'm done with this x. Now I move on to this. 4 times x is another 4x. Notice that. And this times this is plus 16. So when I finish it off, I've got x squared plus 8x plus 16. Now, all of these things are equivalent. They're all the same, just different forms of each other. Now, at the end of today, towards the middle of today, I should say, we're going to start with this, and I'm going to want you to get back to this. So I've got to study where did all these pieces come from? How can I find a pattern? Just like I talked about, a cow has certain characteristics. Remember? We talked about that stupid little toy that you had. If you were a cool kid and if you were deprived, you didn't have it. Do you remember us talking about that? I felt like I was playing the slot machine. You guys don't remember that? Talks about how like you would pull it and a cow says moo, and there was that little toy that would have a little spinner in the middle, and you could pull it down and it goes, cow says moo. Remember that? If you don't, sorry. Mommy didn't love you enough. I'm just kidding. And you would pull it, and what it was training the kid what a cow looks like. It had a picture, it showed what it sounded like, and then it had giraffes, it had chickens, and it was for a little kid to study, but it felt like a toy. But it really was teaching. We're doing that same thing here. We're going to say, what do perfect squares look like every time? What are their characteristics? So that way when I go to a problem and I see it, I go, that's a perfect square. Because it carries the same characteristics every perfect square has. We are diving in. Doesn't this sound a little bit like science? Isn't this what you do in science? You study what rocks look like. Right? The ones that you're supposed to kick rocks when people tell you to. Do you study the ocean? You study animals in science? Their characteristics? Yes? Yeah. Math is a science. We're studying numbers and equations and what they look like. Their characteristics. What do you notice about this number right here? Or this? Yeah. What do you notice about it? Squared. Which means it has a square root. So this right here has a square root. What does this have right here? $16 also has a what? The square root is 4, by the way, right? So that's going to be some key characteristics when I'm starting with this and I'm trying to work backwards. What do I notice about the front number? It's got to have a what? has to have a square root. What will I notice about my back number? It also has to have a what? If it doesn't have those characteristics, what do I automatically know? It's not a perfect square, because perfect squares, the front number always has a square root. The back number will always have a square root. And if I check that and it doesn't work, then I go to my next steps in my factoring. Are you following me? Okay, so here we go. What about this middle number? Watch where the middle number comes from. Do you see this right here? What do you notice about that? There's two what? There's two 4x's. Do you see that? What's the square root of this? What's the square root of this? Do you notice something about those two numbers? What is this right here? What is this right here? That's going to happen every time. Except the middle number, here's why it's tricky. The middle number is this, the two square roots times together, but then doubled. Every single time that will happen. Let's look at another example and see if we can start seeing this pattern, because sometimes just looking at more examples will help us out. Let's start, again, we're going forwards until we see the pattern, because that will help us go backwards. So let's try a different one. Let's try something like this. I am going to write down what that will look like as a trinomial without having to do all that work. I will be able to write right next to this without doing any work. I can do it all in my head because I know the pattern. At the end, after we FOIL this, which we're going to do together, this is the answer we're going to get. It will be 4x squared plus 24x plus 36. Isn't that really nice that I can do that without having to do all that work? Do you know why I can do that? No. I know the pattern. You can make one up and I could do it. I know the pattern. The pattern says I'm going to do what with this? Square it, right? That's what that front number is going to be. Where's the back number coming from? The 6 doing what? Squaring it. Where did this middle number come from? What did I say? These two, if you remember, look. Didn't I start with a 4 and an x? What did I say was down there? 4 and an x, and I times it by 2? Hey, let's look. This times this is what? 12x, and times it by? Boom, that's where I got the 24 from. That's the pattern that's going to happen every single time with a perfect square. We're studying its characteristics. That's what's going to happen every single time. You're not going to find one that doesn't do that. There are no exceptions. That's why I loved it. What do we think? Yes. 2x times 6 is, and I times it by 2. Because there's, in the middle, how many of those 12x's am I going to make? 2 of them. Remember here, let's go the long way. Let's show it working out again. I think if we just drive this home for one last time, it'll make sense. If I FOIL this out, what do I first do? 2x times 2x, which is my 4x squared. That's why I just squared this. 2x times 6 is 12x. That's that 12x I was referring to. But again, 6 times 2x is another 12x. That's why I have to double it. And then 6 times 6 gets me that 36. So hopefully we're seeing the pattern and where all these numbers are coming from. Now, Mr. Martin, how does that help me factor? Because I've seen the pattern, my eyes have been opened, I know how to work backwards from this. So here's how we check this. By the way, what does this sign always have to be back here? Someone tell me why it would always have to be plus sign back there. Yes. In order for it to be perfect square, you have to times it by itself. So if this is a positive 4, which it is, times a positive 4, what's a positive 4 times a positive 4 going to give me? Positive 16 in the back, right? Well, let's try a different way. Let's do a negative 4. Let's pretend this is a negative 4 and times by a negative 4. What's that going to get me? Positive 16. Negative times a negative, okay, gets me to a positive. So back here, now, could this be a plus and this be a minus? Not for a perfect square, because it's got a perfect square. It's always times itself. So the only thing that you can happen is a positive times a positive or a negative times a negative. Does everybody follow what I just said? So what's one check real quick is, you know that the back number always has to be positive. If it's not, blow right past perfect square. You know it's not perfect square because they have a certain pattern. Let's figure out what that pattern is. We're going to start off with some easy ones. Notice, what did I give you this time? How did I start the problem off? I started off with the answer when what we were trying to get to last time. Now we're starting at the answer, and we're going to work back to the problem that I gave you at the beginning. We're going backwards now. Now we've switched directions. Now we've started here, and I need you to get me back to that. To at least understand where we're starting at and where we're going. All right. Here's how you check for a perfect square. What happened every time to this number? What did I know it has every time? I wrote it down. It has to have a square root. It has to have a square root. Does this have a square root? Yes. What's the square root of x squared? So that's my first check for perfect square. I look at the front number and I go, do you have a perfect square? Or a square root? If the answer is yes, then I keep going through my checks and go, okay, maybe you are a perfect square. Does this have a square root? What is it? So I'm going, ooh, oh, I might have a perfect square here. Before I check the middle one, though, what does this have to be? That has to be plus sign. Don't forget that. That is a plus sign, so we're going, oh yeah, I'm feeling it. Right? This is going to be a perfect square. I'm talking to myself, being a weirdo. That's what math people do. If you don't, you better get on the train. My final check is this times that is what? But I wasn't only supposed to have 1, I'm supposed to have 2, so I double that. Is that what's sitting right there? I know this is a perfect square case, and I just throw my bubble down. What's going to go inside my bubble? Is that number right there and that number right there. I put an X, I put a 3, and I square it. Notice what I left off. What goes in the middle? Does this sign right here tell me what goes right there? No. What does this sign always have to be? Always has to be positive because they both have to be same signs. So that does not tell me what sign goes in there. This sign right here tells me what goes there, and since it's a positive, I put a positive there. This is the sign that tells me, not this one. That always has to be a plus. This could be a plus or it could be a minus. You following me? We're looking for proficiency through this, right? 100%. We got this. All right? By the way, I'm making these problems up on the fly because I know the pattern. I can make them up in my head because I know where they come from. Does that make sense? I'll show you how I make a problem up in just a second. I'll encourage you to learn how to make a problem, because if you can make a problem up, you darn sure know exactly what you're doing. You've got to know the pattern. Perfect for that. my first step in every time I factor? Greatest common factor. I know that we're working in perfect squares, but I need you to remember that step. Always try to find the greatest common factor. Do they have anything in common? No. Next step, look at special cases. Is this a candidate for perfect square? How do I check to see if it's a perfect square? And I look real quick. Does this front number altogether have a square root? What is it? 2x. Don't forget that. Make sure you write that whole thing up there. Not only does this have to have a square root, but the number that's attached to it also have a square root. Does this have a square root? What is it? My next step, don't skip over this one. What has to be there? This plus sign has to be there. Is it there? My final check. Here we go. We're going to see, is it a perfect square? 2 times 5 is 10. Times 2 is that what I have right there? So what happens? So where we're at, we said 2x times 5 is 10 times 2 is the 20 that's there. Is this a perfect square case? Yes, it passed every test. Hopefully like you will. Does everybody see? This number right here went right there. This number right here went right there. So that's why I write them down. Now, where does my sign come from? This right here is the sign, and I put a minus right there. And there it is. It's factor. Thumbs up, thumbs sideways, thumbs down. Good. Great. Yes?
Doesn't it have to be both negative or be squared?
Yep.
Why is it plus?
Right here? No, that has to be a plus. Because you're going to have a negative 5 times a negative 5. And what's negative 5 times negative 5? Remember, that's what we were talking about. How same signs, you're going to end up with a positive back there.
Yeah. Positive 25.
Yep. Okay. See what you got here. See what you got. I'll give you like just a minute real quick to see what you got. Probably less than a minute because I can't stand just sitting up here. I know you're probably fast forwarding the start of the video. See, I'm talking to you in the future. Kind of weird. Hopefully I'm talking to you in the future. That means you're watching the videos again. If you never watch the video, you'll never. And I'm just talking to myself. Oh, it's getting scared in here. Tricky. All right. First step. What was the first thing you should have tried on this problem?
Check to see if each side is
Nope. And I know I'm harping on it, but I want that to be the thing that comes to the forefront of your mind every time you see GCF. Right? GCF. Is there one? No. So we skip over that. I understand. Second step is to check for special cases. Is this a special case? It has a possibility, right? Is this a plus sign? So what one could it be so far? Perfect square. Difference of squares, they stick out like a sore thumb. When we get to those in just a minute, I think those are the easiest ones. I think they're cake. They stare at you dead in the face. They have a huge warning sign, like big time teller. Does this have a square root? Which is what? Does this have a square root? Which is 4. Is this a plus sign? Yes. 4 times x is 4x times 2 is this a perfect square problem? It's not. So guess what? It failed the perfect square test, so I move on. That doesn't mean I can't factor it. It means now I look at what? Go to step 3 on your factoring. We did this all the other day. Look at A. Does A equal 1 in this case? Yes, it does. Double bubble right away. It turns into what we did last Friday. I need 2 numbers that multiply to 16, but since they're same signs, and I need 2 numbers that multiply to 16, but add to 10, and both signs are going to be what? So I know negative, negative. I throw an x, 2 numbers that multiply to 16, but add to 10, 2 and 8. 8 and 2, doesn't matter which one, remember? Perfect. Does that make sense now? This is how you are going to go through this. This is called problem solving. We can't baby you anymore. I'm not going to be able to throw a problem because there's going to be 4 different parts like I showed you, and you're going to have to go, okay, I need to factor this one. What are the possibilities it could be? Okay, I need to factor the second part, the third part, and the fourth part, and they're going to be all mixed up. One might have a GCF, one might be a perfect square, one might be A equals 1, one might be A is not equal 1. You better know all 4 ways of factoring, or guess what? You'll never get to the algebra 2. Because your algebra 1 will keep you stuck where you're at, and you'll never be able to go on with that problem. And the sad part is, when we get to the algebra 2 part of that problem, it's cake. Don't let your algebra 1 skills hold you back in algebra 2. How do we feel about this so far? Do we need any more? What's up? I'm not trying to scare. I'm going to prepare you for the battle that we got ahead, and I'm going to be dead honest with you. I'll tell you, listen, if you follow me, if you can factor like a champ, that problem right there is super easy. That's why I'm spending this much time going over factoring. You can't factor. Yeah, you'll see why. Factoring goes all the way to calculus and beyond. It's going to be it literally becomes like addition, or subtraction, or multiplication. It's a big part of all of our math.
Voice.
Mm-hmm.
Voice.
Yeah, especially if you get it. Because you're going to go to these other classes and the kids are going to be stuck on factoring. You're going to be like, I got that. All right, difference of squares. I told you these guys stare at you in the face. Here's the reason why. Difference of squares. Here's what they look like. Notice I didn't save hardly any time for them because here's what a difference of squares looks like. Going forwards. What do you have here? X. What do you have here?
X.
What do you have here? And what do you have here? What's the difference? This is a plus, and this is a minus. That's why we call it difference of squares. It looks like you're going to have perfect squares, right? Perfect squares are where you multiply it by the same exact thing, except there's one difference. One is going to be plus, and one is going to be minus. Now let's go forward through this and see what happens, and see if we can develop a pattern, just like we did for perfect squares. There's going to be something that happens that goes, oh, I know how those are made. So here we go. Let's do Christmas today. X times X is X times the negative 2 is 2 times X is A. And this times this, positive 2 times the negative 2 is a negative 4. What happens right here? Every single time, the middle will cancel out. And what are you left with? What's the difference? Why is it staring? So remember, we're going to be looking at this. What's the tell that's going to say, hey, you have a difference of squares problem, so that I know from here how to get back to here. What's the big difference from the last one that I was showing you? And all the other ones we've tried to factor. How many terms have been in all the other ones? 3. How many terms are here? Do you see the big thing that's going to stare you in the face and go, this is probably a difference of squares? It's only going to have two terms. Little two change reference in there. No. I told you, if you don't like it, get out. It's ugly up in here. Okay? It's not only going to have two terms every time. That middle part is going to cancel out because you're going to have one being positive and one being negative, and they're going to make each other disappear. So what are the things that I noticed? What are some characteristics I know about this? This has a square root, doesn't it? This also has a what? That's because they're both going to be almost identical, right? That's going to be the square root part. But the main thing is, what does this have to be? Has to be a subtraction. Has to be a subtraction sign in there. If you have this right here, does this look like a difference of squares problem kind of at the beginning? Yes, because there's only two terms. But where, and does this have a square root? Yes. Does this have a square root? Yes. But what's the problem? That's a positive sign. That's an algebra 2 problem. We're going to talk about this situation when it happens in math. And you know how you've talked about real numbers? You ever heard of that in your math teacher? He talks about how all real numbers, and you're going, why do you keep calling them real numbers? Why can't you just say all numbers? Why do you have to have that word real? Because this year we're going to learn about something kind of like your friends, imaginary. Okay? We're going to learn about imaginary numbers. Okay? They're easy too. It has to do this idea with, do you remember how, and I hope your Algebra 2 or Algebra 1 teacher didn't make this mistake. We sometimes say things that we shouldn't in math. I hope your teacher never ever said something about you can't have a negative under a square root. Did they say that? Okay. You can have a negative under a square root. But you can't have one in the real number system, which when you were in algebra was what you guys were dealing with. When we get to this guy, it's called an imaginary number. So what your teacher should have said is, you can do this, but not in this class. You're going to learn about that later on. Do you remember when you were little and you learned about 1? What was the next number your parents told you about, hopefully?
2.
2, right? Did they tell you about 1.135789 fiber? No, they didn't. Why? Because when you're first learning your numbers, you don't need to know about the ones in between. We just start off with the easy. Let's go with 1, and then 2, and then 3, and then you get a little bit older and we talk about 1.5. Then we start talking about, we fill you in as you get more mature, right? As you get more mature, we start showing you other numbers like this, which is going to be imaginary. We're going to deal with that this year, and they're not scary at all. It's just, again, filling in. There's numbers between 1 and 2. Think of it like that. All I'm doing is just filling in a little bit more of the gap that we've done on purpose. We stagger it for you. As much as you think we hate you guys and we try to make math hard, we've thought about it and we try to make it as easy as we can. All right, try this. Hopefully you're going to find difference of squares as easy as I do. In your brain, there should be like a red light flashing. Bam, 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 difference of squares, like alert. Why is there alert going off? What sets it off? Just say it. Negative? This negative right here sets it off, but even more than that, what's the big thing? There's only 2 terms. There's only 2 terms right here, so I go, whoa. This is probably a difference of squares problem. Don't do this one. Because even before that, what should I... we can do it. It's okay. We can do this out. There is a greatest common factor. What's the greatest common factor? And so I could pull that out, and this would still work. This is still actually how you would do this problem properly. So I don't want to change it. What would be left over? X squared minus 4. Now, is there still potential for a difference of squares? Yes. Does this have a square root? What is it? Does this have a square root? What is it? Is this a subtraction sign? It's a difference of squares problem. It passed all my tests. 4. What goes in my bubbles? The x and the 2 are going to go in my bubbles. I'm going to throw an x and a 2, an x and a 2. And why is it called difference? One's plus, one's minus. Problem done. Moving on.
It doesn't matter which one is plus or minus.
Not at all. Do that one real quick. Hey, you got to be my timekeeper. 45, right? Oh, you're right. We have, but from now on, I might have you set an alarm in your phone. On the test, if I give you this problem after today, how long should this problem take you? So if I put this as a problem on the test, I think in my head, that's a difference of squares problem. If they know what they're doing, it should take them 10 seconds. If you don't know what you're doing, it's going to take you longer, and what's going to happen to you? You won't finish my test because it's taking you too long. Look how long this should take. Hold on, don't pack up. I'll give you time. Okay, GCF. No. Is this a special case? Well, I look and I go, my light's going off. There's only 2 terms. Square root of this is x. Square root of this is 9. This is subtraction. X plus 9. X minus 9. That's how long it should take me. What do we think? Then tomorrow we'll come in and we'll wrap this up with a equals does not equal 1. And we'll finish it up.